Hi to all. I am Yashodha from Computer Department. Today we will discuss about networking devices. Now we will discuss about what is the basic introduction of networking devices. Networking devices are are also known as hardware devices, and it helps to connect to manage some computer networks, that is a modem, a repeater, a hub, a switch, a router, a bridge, etc. And these devices are communication between different devices and facilitate the data transfer. సో ఒక డేటాని ట్రాన్స్ఫర్ చేయాలి అంటే మనకి ఖచ్చితంగా ఒక డివైస్తో మనకి కమ్యూనికేషన్ అనేది ఉండాలి. సో ఇందులో కొన్ని కామన్ డివైసెస్ వచ్చేసరికి మనకి రూటర్స్, స్విచెస్, హబ్స్ అండ్ మోడెమ్స్ అన్నమాట. సో నౌ we will discuss about what is router. So we see in diagram, in a diagrammatic way, this is the wireless router, and wireless router is directly connected with a system and internet, and also connected with printers, and also connected with our phones also. This is the wireless router, and the router, it is essential for networking devices that connected to multiple networks such as internet. We will discuss internet, computer, our printer, our phone, etc. Such as LANs and WANs. LANs means local area network, and WAN means wide area network. So they are forward the data packets between the networks based on the IP address. It depends upon the system IP address, and the routers are also provide to security feature. This is the one of the main advantage of routers, that is security. And also one of the main example is firewall. Also the firewall and routers are the wireless home network devices, and it helps to protect our network and translate the data, that is network address translation, NAT. Now we will discuss about what is switches. In these switches we are used to connect devices within the networks such as computers, servers and printers. Here is some example of our switches. Here some workstations and Wi-Fi and switches and servers that are basically connected with our computer. They are directly connected with PC and directly connected with workstation and connected with the server, and it is provide to the efficient connection between the devices, allowing for a faster data transfer. సో డేటాని కనుక మనం ఫాస్ట్గా ట్రాన్స్ఫర్ చేయాలి అనుకుంటే మనం ఈ స్విచెస్ అనేవి మనకి చాలా చాలా ఇంపార్టెంట్ అనమాట. అండ్ ఇట్ ఈస్ ఆపరేట్ ద డేటా లింక్ లేయర్ ఆఫ్ ది OSI model, objective model, and used to MAC addresses of the data to forward the messages in one by one. And now we will discuss about hub. Hub is one of the most feature in networking devices, and this is also called as a physical layer also. In this physical layer it is directly connected with multiple devices on a network, and it operated with OSI model, and it is also connected to all broadcast data devices, and these hubs are helps to efficient connection between the switches, because it is created to a limited bandwidth. Here we will see in a diagram, these are the multiple systems that is connected with one to another, and these are also called as the repeaters, and here it is connected with entire hubs, that is called Ethernet. Now we will discuss about modem. What is a modem? In simply way, the modem is also called as a modulation and demodulation. So that is, we will send a message in a modulation model, and then modem will transfer that message into analog signals, and the modem transfer into analog to digital also, and we will the server receive the message in normal language, that is our English language. The modems are to connect the digital signals to analog signals. We will see in diagram. Suppose we will send a message from one person to another person. The modem is modulate the message, and the message follows to through telephone lines. After another system modem will demodulate our message and then go to the server, that is reply. These are essential for connecting to the internet via DSL cable networks and dial-up connections. It is also provides modulation and demodulation functions to facilitate the data transfer between the devices. In between the devices is called as a modem. That is, next we will discuss about the wireless access points, that is called WAPS. It is a wireless access point to transfer and receiving the data through the wireless signals, and it provides the network's infrastructures and also allow to the device to connect the internet wirelessly. Here see the diagram. The wireless controller, there is no wire in between the areas, and it is also the one of the main example of Wi-Fi. So the wireless standards, it can be used in the Wi-Fi's or used also, as you know, you are also used in Wi-Fi's in our homes and offices and other public areas. So these are the wireless access point. Now we will discuss about network interface cards, NICs. So in this network devising topics, the NIC is also a hardware device and enable to computer to connect a network. So these NIC is used to make mesh networks, that is managing to the troubleshooting networks also. It is installed in our PCs and attached with our cables also, and it provides a physical connection between the computer and the network using the Ethernet or wireless technology, as you know the Wi-Fi in the previous sessions. And the NIC, the network interface card, are unique to the MAC addresses that are allowed to the computer to send and receive the data over the network. In this network, interface cards are used to transfer the messages to in between sender and the receiver also. The data is transferred very efficiently. Now we will discuss about NAC. NAC means network attached storage components, and it is used to store the data and connected between the network and provide a centralized storage and file sharing. They are allow multiple users to access and store the data to shared a network drive, our network drives. Here we will see in memory bank and memory bank processors also, and the chipset also. The memory bank in to save our data and process the data, and it is also used in the backup option also, and remote access also is in it is used in this network. The network attached storage is used to ES files sharings, that is our files are shared in a network and through the network attached storage, and also we will share the files in systems and backup our files and download it also. Next we will discuss about repeaters. These are the one of the main important networking devices that are used to share our data from sender to receiver. So this is also used in extended the range of the network by retransmitting the signals, that is we are transferring analog signals, and the repeaters also retransfer the analog signals also, and it is regenerating and clean up the signals and reach to destination without degradation. These are the commonly used large networks to overcome the signals loss over along the distance. We can see in laptops also and PCs on our systems also, we can transfer the data, and the repeaters also transfer the data into router, and then router transfer the repeaters, and repeaters also transfer the system in vice versa manner. Next, we will discuss about overall networking devices. These are the summary of the networking devices. So we can use this hub, router, repeaters, modems, bridge, switch. These are also the networking devices. It is play a vital role into establishing and managing the computer networks. Through these are the commonly used networking devices, and each device has a specific purpose and its functionality to contribute to the overall efficiency of the networking. So this is the overall summary of the networking devices. Now we will discuss about the error detection and correction. Firstly, we can what is error detection and what is error correction. We can see in diagram, the error detection block diagram. We will see in error detection diagram, the sender is in block and the receiver is in the block. The sender send a message that is encoded, and the receiver receive the message in encode to decode. That is, we will discuss about modem also in topic particular. And the data word generator code word. It is unable to transfer, code word is not unable to transfer, that is n-bit data, and the data word is transfer sender to receiver, that is k-bits data, and then the sender send a message to the receiver, the error detection is not there, and checker and generator, we will generate the message and transfer the data. Amma. So now we will discuss about the error detection and error correction. The error detection is we will see in a diagram. Our data is transferring sender to receiver. The data is unable to transfer. This is unreliable data. Suppose we will send a message that is probably transfer go to receiver. It is not possible. It is some errors is in errors అనేవి వస్తాయి. Okay, so that's why the data is transferred in word to word, that is data word, and we will check the data, and exact data we will send the receiver, and the receiver taken the data to ensure the integrity and reliability of the transmission information anamata. So by identify these corrections of errors, the data can be accurately and received the processed. And what is the error correction? We will see in the diagram the same error detection and error correction. We will see in the unreliable transmission also is in there, and the encode the data and decode the data. One of the main important in this. And now we will discuss about the types of errors. See in this diagram there is two types of errors, that is a single bit error. So first we will discuss about a single bit error. It is occurs when only in one bit in a data, that is unit is altered. The single bit errors are involved to multiply bits being the corrected in the short period of a time, and it is unpredictable to occur at any point to transmit the data. The single bit error is at least likely the type of errors and the serial data transmission, because noise but have very short duration, which is very rare. In this single bit errors, we will see in this diagram there is we will send 01000010, and receiver take we will 1 will change in zeros, and 0 change it 1. So these are called the single bit error. and these are travel a serial data transmission, not it is not a serial data transmission, it is a parallel data transmission. Why? Because they are sender and the receiver will send messages parallel to one device to another devices. That is called a single bit error. Now we will discuss about the error detection techniques. They are the error detection techniques means priority checking. So priority checking, checksums, and CRC means cyclic redundancy check. These are the error detection techniques. These are mainly we will discuss in single bit error detection, and we will discuss about priority checking error detection. It is add extra bits to the data unit, and it is add original data. We will see in diagram, this is the original data and this is the row partition data and column partition data. The original data can be sent into receiver. The data will converted into this. Now you will see in below the data to be sent. So original data we will see in 1001101, and now the data to be sent to the receiver, the data transmission will 100110010. The 1 is become 0 and 0 becomes 1. So these are the error detection techniques. And now we will discuss about checksum methods. It is calculated to generate the error detecting codes also, and it is also a advanced method. Advanced method we will discussing the polynomial codes, that is called CRC, cyclic redundant check, and these are used in columns and row partitions also. So these four techniques are used in error detection techniques. Now we will discuss about priority checking. In this priority checking, we will transfer the data in priority order. Now we will see in diagram, this is the original data 1001001. The sender transmit the data. The data will be changed in 1001001 and 1. So originally we will send 7 bits of data, and the priority checking will add some extra 1 bit of data. That is called priority checking can detect to the single bit errors also, and it involves to add extra bit to the data unit to make the total number of ones either even or odd. And it receives the data has different priorities than expected, and error is detected. Now we will discuss about checksums. In previous sessions we will discuss some small example, small definition, and we will discuss in checksums are thoroughly used in network communication protocols. In this diagram we can use receiver and sender. The sender first we can selection 1, selection 2, checksum, selection k, and so on, and the sum complements to 0, it keeps to otherwise discards. The checksums are widely used in the network communication protocols, and it is add upon the all data bits to generate a unique sum. It received to calculate the receiver data of the sender, and it is compared to transmit the checksums. If there differs, an error is detected or not. The checksum is used in another network device in this error detection. Now last we will discuss about cyclic redundancy check. In the cyclic redundancy check, the data is transferred into divisor and CR. That is, the data is used to various applications that is treated to data transmit the binary number to the perform the polynomial divisions. The division is appended to the data as an error detection code. In this diagram we will see in a sender and the receiver. In this sender we are receiving normal data is 00 data, and what is the cyclic redundant check? The cyclic redundant check, the data transfer we will send a data. The data will be check in cycle redundance, and the reminder we will use to 0 number of bits transfer. And now we will discuss about error connection techniques. The error connection techniques is the process for requesting the data transmission to be resent. It is commonly used in error correction technique to retransmission the data, and it is forward to introduce the redundancy transmission data to allow for the error corrections. The Hamming codes are also used for error corrections in the computer memory. In this error correction, they are used in ARQ protocols, that is a half duplex technique protocols. And if we send a message and wait for the sender, then the next message, the receiver receive the message and send to acknowledgement, then wait for the next message. This is the complete stop and wait half duplex technique. And what about a full duplex technique? It is used to sender continuously sending a packets without receiving the messages to the acknowledgement, and then receiver continuously receiving the messages without acknowledging the right way. These are the automatic repeated request in this error corrections techniques. Now we will discuss about automatic repeat request. They are involves to retransmit the data when errors are detected. The receiver sends an acknowledgement to the sender upon the successful recipient of the error-free data. If errors are detected to receive the request, the sender to transmit the data. So the sender is continuously transfer a message, the receiver not receiving the message, receiving the message in continuous way, that is also called as automatic repeat request. Now we will see in diagram the source and destination is in there. Source means our sender and destination means our receiver. The source code in the encode to transmit the data, and the data will be modulated. Modulate the data to go to transfer channel, and the receiver then go to demodulate the data and decode the data. Next, transfer the data into destination. So these are the automatic repeat request. Next, we will discuss about forward error corrections. It is also used in the situations in where retransmission is not practical, and it adds the information to the transmit data to allowing to receiver the correct informations or correction of errors. The Reed-Solomon codes are widely used in forward error corrections in these applications, that is CDs and DVDs. These are used and one of the main application is satellite communication. Also the forward error correction code. In this forward error correction code, we need to recover from lossless, that is Reed-Solomon codes. In this code, we will use it in every part that is constructed in a number of parts, priority parts, and it covers all the data packets from more than n number of losses. And it is the plus point is redundance loss probability, and the minus point is greater overhead and end of the hosts. Now the last conclusion of the error detection and correction is a technique to play a vital role to ensuring the reliable data transmission. And in this error detection and correction, we have some different techniques which are used to priority checking, checksums, CRC, ARQ and FEC. These are implementing these techniques by data integrity and accuracy can be maintained in our networking devices.